Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CACHEFLY.com.
On this episode of Know-How, we're going to be continuing Project Arduino. We're starting up Project Alien X, and your feedback, our answers. Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballasare.
And I'm Brian Burnett.
And for the next 4 or 5 hours.
At least.
Yeah.
This is going to be an endurance run of Know-How.
Yeah.
24
exactly.
hours.
24 hours
of
Know-How. Of no-hole. Knowledge holing.
Until there's nothing left.
Yeah. Oh, no, but seriously, we're going to be bringing you some of the projects that we've been working on in the past couple of weeks.
Geeking out.
You can geek out like
Having fun.
Geek out.
Yeah. Because we don't have enough things to do, so we get to fool around with this kind of stuff all week, right?
But before we do that, speaking of endurance marathons of knowledge, there's another kind of endurance thing that you actually know about.
Yes, the 24 hours of Le Mans.
Now, of all the endurance races, I've heard of Le Mans and I've heard of Baja. Like, if you know nothing about racing,
oh, like the Baja 1000.
Yeah, you'll hear about those. But Le Mans actually has kind of it's an interesting history. Where did this race come from? Why do they do it? Why is it so popular?
Well, they started a long time ago in France.
Which makes sense.
I don't know all the specific details of the actual race, but I want to go to it. I might be invited to go later this year.
Right. Oh, no way. Really?
Yeah.
I think it's in June, right? It's like June 13 through 14. It's at this. I'm sorry, anyone who actually speaks French.
De la
Circuit de la
Yeah. Bonne nuit.
Yeah.
Thank you.
But okay, now let's go beyond just the location and the historicity of the event. You've been at an endurance race. What's so special about an endurance race?
Well, unlike where most races are a contained number of laps and it's just an all-out sprint to the finish line, this is more of a... The way I experienced it in Daytona was a long... It was like a chess match where if you make one mistake, it could ruin the whole thing for you. And it was like a demolition derby just waiting to happen, because there's so many things going on. There's the different classes of cars, and they're all competing against not only their class, but the other people out on the track. So most races, it's just one type of car. They're all relatively the same speed, and it's down to the drivers to kind of get around each other. But with the 24-hour endurance races, they're weaving in and out of, like, there's the prototypes, the Le Mans cars, the GT cars, and they all have, like, they're all fast, but some are much faster than others, and they have to be very careful about not hitting each other. And they switch out drivers. So that's like another level of complexity.
I actually had a question about that. When you switch out drivers, is there strategy on where you put your strongest drivers? Do you want them at the beginning? Do you want them at the end? Or I mean, does it not matter because it's so long?
It matters. It does matter. I mean, hopefully, if you're putting a team together, all your drivers are strong, but that's not always the case. But usually, the way when I was working close with the team here that's out of Petaluma, they would have their strong driver do the qualifying, because that's the important, your starting point.
Your position.
And then you want your strong drivers at the end of the race too, because as the clock ticks down, those last few hours of the race, that is like a sprint. That is the race. Everything leading up to that point is just trying to get to there without breaking something, without someone having fatigue and then crashing into a wall or something like that.
Yeah. So basically, what you need out of the driver in the middle shift is just
consistency.
Maintain. Maintain your position. Don't crash.
The way it was described to me was, let the other people make mistakes and you just focus on what you need to do. And if you lose a few seconds in a corner, if you get a green shell thrown at you, Just try and maintain consistency
Actually, that's
in
the other
first
question.
place.
Is there a blue shell in Le Mans? Because, I mean, I would think that would be a vital weapon.
You know, I think the blue shell is another car coming at you and not hitting the brakes.
Now, we're not here just to talk about Le Mans. We're
Right.
here to talk about a specific company that's going to be competing in Le Mans, but they've brought kind of a crazy entry.
Yeah, the Nissan GT-R LM Nismo.
This thing looks weird. This is not
Yeah.
what I expect a race car to look like. This is what I expect like a show car to look like. I mean, so this is the GT-R LM Nismo. It's 1,250 horsepower. It's 1940 foot-pounds of weight. So I mean, this thing is ridiculous power to weight ratio. But the coolest thing about this is what they're doing with the aerodynamics and the powertrain. They've basically taken the racing world and what we know about how you design a race car, and they flipped it upside down. For example, race cars are never front engine, right? You always want to have
front engine.
yeah, never front engine and never front wheel drive. Why don't you want that?
Because if you have too much weight over the front of the car, you get understeer, and it's harder to go fast when you're understeering instead of you can control oversteer a little bit better.
Right. So most race cars are either going to be rear-wheel drive or all-wheel drive and mid-engine, right?
With a weight ratio of like 50-50.
But Nissan has decided to put the engine up front, and they've made it a front-wheel drive car.
What?
And what they've done is they've said all the disadvantages that you just mentioned, the wrong weight distribution and the wrong type of traction is actually made up because with putting all the heavy, big stuff up front, they can streamline the aerodynamics of the car and it actually runs faster.
But okay, so I wonder, it might go faster, but will it turn quickly?
Well, I mean, that's what they're saying. So when they were designing this, they wanted to solve for that. They wanted to solve for weight distribution, and they wanted to solve for oversteer, understeer. And what they found out was by putting like the coolers up front, they could get all of the air they needed to cool down the oil and the engine.
Makes sense.
And then they could streamline the back of the car. Essentially, they can turn the entire car into a spoiler. So this thing hogs the ground like you wouldn't
it
believe.
looks like a wing. It
does,
just looks
right?
like a wedge.
It's a wedge. Now, they've done that in the past by either messing with the spoiler, but there are limitations on how big you can make that. They've also used things like blown diffusers to kind of stick it to the ground.
Yeah.
But this is the first time that you've had an entry with a lot of cash behind it that has said, no, we're going to do a design that's completely different. Now, we have no idea if this is going to work. I mean, it could just fail out of Le Mans.
Pretty cool.
But yeah, right? The fact that they're doing something different, I kind of like that.
And that's not the weirdest car I've seen at Le Mans. There was a tri-wheel car where it had one wheel in the front and two in the back.
Wait, one in the front?
One in the front, two in the back. I forget what it was called, but it seemed to spin out a lot. It was fast.
That car. I don't think I want to drive it.
Yeah. Without four tires, you're losing that much more traction.
Taking a corner at like 150 miles an hour with three wheels.
You got to be brave.
You got to be brave. You got to be brave. But we'll see. I mean, so this event's going to run in June, and we'll see how it works. If it even shows, if it lasts the 24 hours, you can probably expect the other teams to take a serious look at it because, I mean, this is the first attempt, and the other teams will start to say, well, aerodynamics really does play a big part.
Right.
Maybe we don't go front engine, but maybe we go mid engine and mess with our aerodynamics in the same way. It's like what happened with the F1 circuit, with Mercedes moving that turbo to the back of the car. And every team is now moving it to the back of the car.
Just wrecking everyone else. Yeah, the part I find fascinating is not only are they trying something new, but you have to be consistent too. You can't just make a car that will race for 16, 20 laps perfectly. It's got to do it for 24 hours with multiple drivers. So.
Yeah. Exactly. If you only have one driver who can drive your super special car, it's not going to last.
No. I'm looking forward to seeing some more of that.
I'm pretty sure I've seen this design before somewhere. I think.
Yeah. The similarities are uncanny.
Batman drives for Nissan? What?
I knew the Batmobile was front-wheel drive.
It's jet powered.
That's messed up. That's really messed up. Speaking of jet powered, it's not jet powered, but we did promise that since it's March, we've gone past the January and February time period where we said we weren't going to do any quadcopter segments.
We've hit that limit.
We've hit that limit, and now we're going to do quadcopter segments. So specifically, people were saying the 250 was nice. A lot of you bought the 250. Thank you very much. It's great because we're getting some great feedback in our Google Plus group.
Yeah.
But the one thing people asked for is they said, I wish I could take better aerial photography, AP.
Yeah,
aerial videography.
that was the level of steps for me. It was we played with the SIMA, and it's like, okay, I've gotten good at this. I want something faster. And then I got the 250, and it's super maneuverable. But then I wanted to strap like a GoPro to it and get some photos.
Because you can put a 250, you can put a GoPro on that 250 as is, but I mean the footage is kind of shaky and it's not great. And people started saying, well, can I mount a gimbal? You could, but it's kind of heavy and you get no performance.
Time to move up.
Time to move up. This is how it works, folks. You get comfortable with one class and you move up to the next class. And in this case, we're moving up to this. This is Project Alien. It's an Alien X frame. Now the idea is it's a 450 class. And remember, when we talk about classes, we're just talking about how far it is between props. But this is a stretched 450 class because, as you can tell, the distance between the front and the rear is actually longer than the distance between the two columns.
Right. Yeah.
Right. And you stretch it for a couple of reasons. One, because it gives you more stability in this axis, which is what a lot of people like. But also, it allows you to fork out these front arms so that you can get them out of the way of the camera, because people don't want to see the props in the arms when you're shooting video.
Definitely.
Right? Now, this is, I played with a lot of 450 class. This is the one I settled on just because it's a nice mix between camera stability and fun to fly. You could go for a straight 450, what's called an X450, which puts all of the props the same distance from each other when you go off the sides. But the problem is it's a boring flight.
It's a boring flight?
It's a good flight for cameras, but it's a boring flight. It's not, I didn't
So
find
you
it that
like
much
to
fun.
do a little stunting or something?
I like a little something.
You'll sacrifice the stability to have a little bit more maneuverability?
A little bit of stability.
Yeah.
But also, this is just a lot more fun to build. Now, what we want to do first is we want to give you all the parts that you're going to need to build Project Alien. So we are doing this 2 weeks before we continue the module, because we want you to have time to order all the parts if you're actually going to build along with us.
Right.
Yeah. So on the table, if you go to the overhead shot, Alex, this is everything you're going to need to build it, aside from the tools. So you're going to need the standard tools. You're going to need some wire cutters, some wire strippers, soldering kit, screwdrivers, ratchet drivers, all that. I'm assuming that you have that in your Geek workbench.
Especially if you've already done the 250.
Yeah, if you've done the 250, you already have all the tools you're going to need. But these are the specific parts that you're going to need for Project Alien. So let's start with this. This is the frame. So we've got a top plate and a bottom plate. They look the same, but the bottom plate's actually a little bit wider and a little bit longer. The reason why it's longer is because of this. This right here, that is a cling plate. So that's going to mount onto this bottom plate with a bunch of rubber dampeners. And what that allows you to do is it allows you to isolate the camera from the vibration of the frame, which is important because if you've noticed that jello effect that you get on the 250, and it's just because the subtle vibrations are shaking the camera enough that you get weird artifacts on the sensor.
Yeah, and one thing that I hadn't thought of, Tony strapped, I think his Sony, I don't know which Sony cam he has, he strapped it to his quadcopter and had the shaky cam.
Yeah.
The mode on, where it's the steady cam, so it tries to adjust for the amount of shake, and that just made it like way worse jello. Yeah.
Well, people always say, well, I'll just turn on the optical image stabilization, right, and that should fix it. No, just
not
because
with that much shake.
It's vibrating so much so quickly that it's counterproductive.
Yeah, that kind of stuff is fine if you're handheld, but and have you ever uploaded a YouTube video where it says your video is kind of shaky? Here, we can fix it for you. Every time I do that, it just becomes like.
Yeah. So we're not going to do that.
No.
Now this frame is actually inexpensive. You can find it for about $18.
Oh, yeah.
Just go to Amazon.com and have it delivered for free.
Good.
Yeah, exactly.
It's currently unavailable.
It's currently, but there's a lot of them. Just look for an Alien X or an X mode Alien frame. You're going to find them.
Can you find this frame on Ready to Fly quads? Or?
They don't do this one on Ready to Fly quads. I would actually suggest you get this one from Amazon.
Okay.
Now, power plants. Power plants are important because you need the motor to give you the power to go, right?
Right.
Right now, there's two motors that I would suggest. The one I would suggest the most is this. This is an EMAX 2213. I buy these on eBay just because you can get a set of 4 for about what, $56 or so. This one's a little bit more. That's Canadian, so that's cool. Now take a look. This is what I like. If you go to the close up here, these are actually set for counter rotation. This red one rotates counterclockwise, and this black one rotates clockwise.
That's a good way to keep track.
Well, they're threaded for that, so that they're actually counter-threaded, so that the rotation of the prop will actually tighten the motor bolt.
Right.
And that gets important when you start getting up to the bigger classes, because we're now dealing with props with some weight to them.
A lot more thrust and spinning. I mean, what's the power to weight ratio on this one?
The power to weight ratio on this one, when I fully equip it, is about 8 to 1. So this can generate 8 grams of thrust for every gram that it weighs.
That's pretty good.
It's not bad. Now the thing is, if that's a little expensive, if you really need to cut back, this is the second motor that I would suggest. This is the Red series. It's a house motor from Ready to Fly Quads. This thing's just $10. So you could get this, and you can get a spare and a half for the price of the other sets of motors. This doesn't give you nearly as much. This will probably give you about a 6 to 1 thrust to weight ratio. I wouldn't use it unless I had to. Like my budget was really crying out for it, but we wanted to give you a lower budget way to do it. Ready to Fly Quads also has some incredible motors that will give you like 12 to 1 thrust to weight ratios. But they can always upgrade.
In price.
Right. We're going to start with this. Past motors, we got to look at ESCs, the electronic speed controllers.
Yeah.
So these are little devices that are going to drive power from the battery over to their motors, right?
Yep.
They allow you to individually control the rotation of every motor.
And what was it last week we talked about? PWM?
Yeah, so these use PWM, right? It's that wave, that squared off wave that will determine how much power it delivers. Now, the ones I would suggest are these. These are the Ready to Fly Quads. These are 30 amps. The nice thing about this is it's $10. And actually, that's about as inexpensive as you're going to get. If you go to Hobby King, if you go on eBay, they're all going to cost more, and most of them are not going to be nearly as good as this.
Yeah, these come with the better software, right? Yeah.
SIMONK firmware, which is what you want, because it means it's refreshing itself more times, so it responds more quickly to your throttle inputs.
Which is definitely what you want when you're flying.
Exactly, because if you have a speed controller that's lagging, it means there's a little bit of delay between the time you throttle up and down. And remember, some people think, oh, you turn throttle on, you turn throttle off. You're always riding that throttle, and you want it to respond immediately so that you can keep your altitude and keep your heading.
Especially if you're coming towards a tree, like somebody happened to somebody this weekend.
I don't know what you're talking about.
With their props exploding off.
They didn't explode. They just they departed.
You're right, along with your camera.
I can't blame that on ESCs. That was me using a really. I knew there was something wrong with the receiver, but I'm like, it's probably okay.
And just well, live and learn.
Folks, quick safety tip: if you ever damage something, just replace it. Okay? Just seriously, just replace it.
It's a good lesson.
I could have saved myself a lot of cash by just replacing that. All right, so that's ESCs. Let's go ahead and look at power distribution. This is actually important. This is how you get from your battery to the ESCs themselves. This is a $2 board from Ready to Fly Quads. It's essentially just go in exactly. It allows you to solder in two wires from your battery, and it distributes that power to everything on your craft. The ESCs, lights, any sort of accessories that you may have. You can make your own harness. People just take wire and they solder together and they put bullets on it.
Yeah.
You can do that. I find this a lot better. It's a lot easier to expand if you're using a power distribution board. And it's $2, so you might as well.
Yeah,
right?
yeah, definitely.
Yeah. All right, so we got our power distribution. So we have a way to get to our ESCs. Now we need something that we can put on the motors to actually generate
to make this thing fly.
Yeah. What I would suggest is pick up a set of carbon fiber props. Now these are 845, so it's 8 inches long, 8 inches from tip to tip.
With a 45-degree angle?
Well, 445 pitch, which means that for every rotation of this prop, it's going to pull forward 4.5 inches.
That's cool.
Yeah, so it's a little bit of aggressive. You can go with a lower pitch and a wider surface on the prop if you want really steady video. In fact, what you can do is you can go ahead and go with a 10 or 11 inch prop on these motors, these EMAX 2213s. and it will rotate slower, which will create less vibrations, which is actually better for cameras. But again, I like to balance it. I like these just because it gives it a lot of zip. Also, this is actually a big one. Let's take an aside because I don't want to talk about batteries right now, but we might as well. This is a 3S battery. This is a 4S battery. This one's going to run at 11.1 volts. This one's going to run at 14.8 volts. So this delivers more power, right?
Right.
Now, we know that motors, if you go way, way back to the episode that we had when we were talking about how motors work, they have a kV, which is how many times they're going to rotate per minute times the number of volts. So you give more volts to a motor, it's going to rotate faster.
Correct.
But they also have a power limitation, the maximum amount of power that you can push through a motor.
Until they blow up.
Until they blow out. They'll melt down. They don't like that. This will run fine with 10 or 11-inch props on a 3S battery. But if you want to use a 4S battery, you need to use 8-inch props because 10 inches will pull too much power through the motors.
Okay. And what kind of flight time are you looking at with these batteries?
With the 2200 pack, I probably get about, 7 to 10 minutes.
Okay.
But like I put a 5000 pack on that and then I get 20 minutes.
Okay.
Yeah. So I mean, it all depends on what you want, what you're looking for. If you want longer flight times, you can actually, I would use a large 3S battery with larger props. It's more efficient. You'll fly longer.
Okay.
But again, the nice thing about this is if I want to sport fly, I can put in the 4S with 8-inch props, and if I want to photography fly, I put in a 10-inch propeller with the 3S pack.
Cool.
Okay.
Right.
And the other thing is we are now moving into carbon fiber. And
I was going to say, have you noticed much of a difference stability-wise between that and like a plastic prop? Or?
It's huge.
Really?
It's ridiculous. Yeah, I mean, let's see, carbon fiber does a couple of things. One, it's much lighter. It's far lighter than a plastic nylon prop, which is important because, again, we talked about this when we talked about motors the first time. The agility of your quadcopter comes from thrust control. How fast can you speed up and slow down props?
Right.
Right? Because that's going to determine how quickly can you change the state of your quadcopter. If you have a heavier prop, it takes longer to spin it up and longer to spin it down.
Right.
So you want as light a prop as possible so that you can change thrust states immediately.
With the most amount of strength that you
exactly. Well, that's the other thing. Nylon props, if you look at a nylon prop when you're flying, it actually bends. Like the tips will start to bend out.
I've taken pictures of my quad before, and in the picture you can see like the wings are bent, like the propellers are bent. Yeah.
And bending props means excess vibration. It also means that you're bleeding off some of the energy that should be pushing. It should be developing thrust. It doesn't really matter on a 5-inch prop. That's why we didn't care about getting carbon fiber for our FPV250s,
right?
Because, well, we're going to crash it a lot, and carbon fiber props are expensive. And also, at that size, you don't see a whole lot of benefit. A little bit, but not as much to justify. I've never broken one of these props. No. Well, okay, I take that back. One of these props was broken when I was in Hawaii. That's because we got stuck in a windstorm, 100-mile-per-hour windstorm.
Whoa!
And it actually blew my prop across the beach. I mean, well, but the
You're
craft,
flying in a 100-mile-per-hour windstorm?
It was on the ground. It was on the ground, and like it literally blew everything from her.
Oh, okay,
okay.
And as it tumbled, it. Okay.
Yeah, they will snap. One other thing, though, carbon fiber props are dangerous. They're not like
they will cut you.
They will cut you, and they will cut you deep. So if you're going to be using carbon fiber, just know, treat it like a knife.
So would you recommend getting both and starting with the plastic props, or just get the carbon fiber ones and save the money and don't hit anyone?
I would say if you've been practicing on an FPV250, your training transfers directly over to a 450 class. So go ahead and get yourself the carbon fiber props. Make sure you've got all your stunt flying out on the 250.
Right.
And then do steady flying.
And fly it outside.
Exactly, and fly it outside. And
not in the studio.
I've only done that once. All right, so we've got our props. Let's talk a little bit about flight controllers. I use a more advanced flight controller in the Alien that I fly for my photography. It does GPS, it does waypoints and compassing, and that's all fine. You can do that, but what I would suggest, since technically we're still kind of reaching out to people who are at the start of their building careers, go ahead and use a KK once more. This thing, this is a $20 board. And this will do everything that you want it to do. But the really nice thing about the KKs is that they're so easy to use. They've got that built-in LCD screen, and the buttons are right on the flight controller, so that if you mount this thing on the top deck of your quadcopter, you can make real-time adjustments in the field without having to have like a computer or a phone or anything. Yeah, this is what it looks like.
I was going to say you've done a really good job of your cabling and stuff, so you have direct access to the buttons without any obstruction.
And you know, you can actually take this and you can move it under the deck. You can put it inside once you have it all dialed in and you want a bit more protection. But with that cost, at $20 and something that's really going to allow you to find the difference between what like the different PID settings do and what the stick scaling will do, it's priceless.
Cool.
Yeah, especially since what we're going to be doing as we build, we're going to show you what each of those settings will do to the characteristics of your craft. It's a lot easier if you can actually see it right on the top of the quad.
Right, because the other one you're talking about, don't you have to plug it into the computer to dial in the settings?
Yeah,
it's an Arduino board?
It's an Arduino board, and I actually have mine set up so it has a Bluetooth module, but it means I have to use my phone.
Oh, that's cool, though.
It's cool, but I mean, that in itself is a project. I mean, we're going to be doing that segment. This is visual. It's right on top, and there's no messing around. You know exactly what you're doing. You know exactly what the settings are.
Because the worst thing is when you get out to where you want to fly your quad and you realize you don't have like something that you need.
Exactly. Like, I've actually done that. I've taken my quad, my nice one, out to you know, I was flying up in the mountains a bit, and it wasn't flying right, and I wanted to change the settings, but I had forgotten the cable, and I was. It was like I had no other. I either fly it like that or I don't fly. If I had still had the KK on it, I could have adjusted down the stick scaling and I'd be good to go. Yeah,
I forgot the SD card on my GoPro once. After I got the GoPro all mounted up and everything.
We'll talk about that a little bit later. All right, so those are all the big ticket items. There are a few other things that you're going to want for this project. You're going to want bullets. These are 3.5mm bullets. Again, there are people who don't like bullet connectors. They just want to solder everything to everything else.
Right.
Totally logical. You could do that. Yeah. I like a little bit more flexibility because I'm always swapping parts in and out of my quads.
Right. And you showed on previous episode, it's not too difficult to solder the bullets together, right?
Right.
Yeah, it's pretty straightforward.
It's straightforward, and you know what? If you do it right, like WITESPY is in the chat room right now. I respect him, and he always says, you're just adding a point of failure. And I know that. But for me, at least where I am right now, because my builds are so dynamic, I'm going to swap it out way before anything fails.
Right, yeah.
But there will come a point where I'm going to go, this is the perfect build, and I will solder everything to everything else, and I will make sure it's bulletproof.
Yeah, because we're still in the stages of playing around with what we like and what kind of models we want to play with.
Right.
And usually the point of failure is between my thumbs, so.
I know, sadly, true. Sad but true. You're also going to need some servo leads. You just need 3 servo leads. If you buy your controller from Ready to Fly Quads, which, again, I don't advertise for Ready to Fly Quads. They don't give us any money. I've been so happy with everything I bought from Paul Baxter, WITESPY in our chat room, and Ready to Fly Quads. They will give you the board. They will give you the leads and the pins soldered the way that you want. Just make sure you check the boxes so that you get those all when you need them. And of course, I'm in love with his ESCs.
If you make good stuff, we're going to want to play with it.
Right. In fact, I ordered the parts we're building an X8. It's an octocopter. Yeah.
Is that going to cut into our snack budget, though?
Snack budget's gone.
We don't have pork buns anymore. We don't have pork buns in like 6 months.
Our pork buns they fly now.
It's probably for the best. They're in here.
Yeah. You're also going to need 14-gauge wire.
Yeah.
So this is good. This is what you need to be able to handle the current that's going to be going through. You don't need that much. I just go to eBay. I bought like 10 feet of this, so 5 feet of each for something like $750.
And you have to get it's silicone.
Yes, this is important because if you get like the plastic sheathed one, that stuff will melt.
Right.
Silicone it's nice and flexible. It will stay flexible.
Right.
It's easier to work with. Don't cheap out on that.
Cool.
Okay.
All right.
You're going to want to get some heat shrink tubing. I got heat shrink tubing in every size in my lab, and hopefully most of you do.
And colorful too.
But yeah, you could just get a pack like this. I think I got this thing for like $5, and it just contains all different colors of heat shrink tubing, which is nice because sometimes you want to color code your connections.
Yeah, keep track of things.
Yeah. You're also going to want a set of nylon spacers. These are incredibly useful. Again, I got a pack. I think this was what, like.
Nylon spacers, yeah, $4.96.
Yeah, so this is like every size of nylon spacer. I actually have a much bigger tub than this, but you can buy a starter pack. These are things that you're not going to exhaust just doing this project. So if you are getting into quadcopter building, buy yourself a nice supply. The more you buy, the cheaper it's going to get, and you're going to use them. Right. I'm always using nylon spacers because they're vital whenever you're putting things inside the internal structure of a quadcopter.
Yeah, I can see it. You've put them to pretty good use down here with the board
everywhere.
And everything.
Absolutely everywhere. And it just makes things more flexible. You also want to get a set of 8mm M3 0.5 screws. So these things right here, you need the 8mm version. I bought this pack for like, I think it was $3, $4, something like that, because I'm going to use a lot of them. You need the 8mm because if it's 6mm, it's actually not going to penetrate far enough into the can. You're going to get a motor that wants to let go, which is bad.
Okay. Yeah.
10mm will actually go too far into the can, and you'll start touching the windings.
And then that's how the Phantom got broke.
That's how the Phantom got broke. So make sure it's 8mm. Again, don't buy small packs, because a small pack of this will cost you like $3. This cost me $4. Buy a big pack, and you'll use them for years.
I've kind of learned that lesson with some of the parts I've bought for the SIMA. It's like, I should have just bought like,
all of them.
All of them at once. Yeah.
Right. Well, actually, there was one point where I'm like, I should just buy extra SIMAs for parts. It's cheaper that way.
Just buy it with the free shipping and then wait a month or two, depending on what you're buying, and just have them on hand.
Oh, well. So altogether, if you want to go the inexpensive route and go with like the inexpensive motors, this build is going to cost you about $160 or so.
Okay.
You can shave, if you have some of this stuff at home, you could shave off like $20 from that. So the cheapest I've been able to build this with the existing support equipment was about $140.
Okay.
If you have none of it, but you do have a radio and a battery and a charger because you've done a build before, it's going to cost you about $170 to $180. If you have absolutely nothing, if this is actually the first build that you've ever done and you need to get a transmitter and a battery and etc., it's going to cost you about $250 to $280.
Ka-ching! Well, that's still, if you're going to get a Phantom, I mean, that's still cheaper than that.
Right. And by the way, that doesn't include the GoPro that you're probably going to want to strap onto the front.
Oh, that's true, yeah.
So,
but I don't know. I think you can pick up the older Hero 3 for not too much.
And we're actually going to talk about alternatives. Like, for example, I lost a camera during my FPV incident. It was a $50 Mobius, though. So, I mean, it's not as bad as losing a $400 GoPro.
Yeah, Black Edition or something.
Yeah. So we'll talk. All of this is going to be in the show notes, so you don't have to rewind this to figure out what I'm going to get. I've actually given you links and prices, so you know exactly where to go to buy it. You've got 2 weeks, so if you buy it today, the way I figured it, if you order all these parts when you hear this, you should have them all in your house by the time we actually start the build.
Cool.
All right?
Can we fly these now?
No. You have to wait.
You bring all this stuff out, and I haven't even gotten to play with it yet.
Well, I built this one for you.
Well, let's go fly it.
This one's going to be yours.
Can we just end the show now?
All right.
Yeah. Okay. Wait, let me grab the quad.
Okay. All right. Now, we will be flying more of these in just a bit, but right now we're going to jump into our crossover episode. If you came here from Coding 101, then you've seen what we had to do coding-wise in order to get the Arduino clock working. We've got Mark Smith, Smitty Halibut from DEF CON, who was guiding us through a little bit of embedded programming. Now we're actually going to show you how the hardware comes together.
Hey everybody, this is Smitty on Know-How. Over the last few weeks, we have shown you on Know-How and on Coding 101 how to make one of these awesome analog panel meter clocks. We showed you the code, we showed you some of the hardware on a breadboard. Today, what we're going to do is we are going to take a prototyping shield for the Arduino, and we are going to hard solder that circuit onto this board so that you don't have to worry about wires falling out, and then you can use your prototyping board to go work on some other project or whatever. The result of this will be a hard soldered kit that you can put together in an awesome box like this and have a final product that you can put on the shelf and use forever. You'll notice that there is one very similar to this, what we're going to build today already in here. The ones that I've used lots of them, but the one that I like for this project is the SolarBotics SB Proto Shield. It says 1.0, but the board actually says 1.1. So the SolarBotics Proto Shield, and the reason I like this particular Proto Shield is that it comes with buttons. It has 4 buttons built into the board already. It's also got some LEDs and some other things on there. We won't be using those, but the buttons are the ones that I really like. It's about the same price. They're all somewhere between $10 and $20 each. I think I got these for $15 on Amazon. Links to these will be, I'm sorry, not on Amazon, from Solarbotics. Links will be in the show notes. But we're going to be using this board with those buttons, leaving off some of the bits that we're not using, since we're not actually going to be using it for prototyping. This is going to be a final thing. Consequently, I'm not going to follow the instructions. Instead, we're just going to install the bits that we want and leave off the bits that we don't want, so we are left with a minimal product. First thing we're going to do is we are going to solder on not the female headers, the male headers. The male headers are the ones that connect the shield into the Arduino. There are a bunch of male headers. There are 4 of them in the kit. 2 of them are 8-pin and 2 of them are 6-pin. If you look at the shield, there are 2 sections of 6 pins over here and 2 sections of 8 pins over here. So we're going to put those headers into these holes over here. Now, also notice that there are 2 different rows. There's the outside row and the inner row. This kit was designed to have a separate male header and female header. The male header is on the bottom like that, so that you can connect it to the Arduino, and then the female header goes on top so that you can plug your wires into it. Since we're going to be hard soldering to this board, I'm not going to bother with the female headers, but we are still going to use the male headers on the bottom. One thing with headers is that you don't want them, they wobble a lot when you put them in and they haven't soldered yet. You really want them to sit flush with the board. And the way I do that is by pushing down on it with my fingernail on the plastic, and that pushes the plastic flat against the board. To do that and be able to solder it all at the same time, the best way I found to do that is to go ahead and solder one in without worrying too much about whether it's flush. Let that solder cool. Then we're going to take the board and I'm going to hold it with my finger. Don't hold onto that pin because you'll burn it, but hold onto the other pins and push it flush against the board, wobble it around while you reheat the solder. When you know it's flush, then you can release the solder, let it cool down, and now you can go back and solder the rest of the pins. And that first pin, start at the other side so you don't accidentally remelt the first one, and that first pin will hold it in place. I'm going to go ahead and do the same to the other 3 headers. Notice how that's kind of off angle. It's a little wobbly from the other one. So I'm going to go in, reheat that solder, line it up, let that solder cool down again, and then it will be nice and straight and in line with the other ones. That's the way we want to see it. Then we go back and solder the rest. One thing to note is that I am exhaling ever so slightly while I'm soldering this and blowing the smoke away from me. Otherwise, when you inhale, you will get a lung full of solder flux, and that's no good. All right, so we have an Arduino shield with straight pins, and we should be able to plug this into an Arduino. You line up the pins nice and straight, make sure none are overhanging on either side, make sure they're all making it into the holes, and plug it in, and it's good. Look at that, it's a shield. It doesn't have a whole lot of useful information on it, or a lot of useful parts on it, so we're going to put those on next. Next thing we want to put on here are the switches. It comes with 5 different switches. These are small tactile switches. They're just 2 pins, very small, simple switches. There are 4 places up here for 4 different switches that you can wire into your circuit. We will only be using 3 of these, so I'm going to leave one of them unpopulated. If you remember from the Coding 101 episodes where we talked about this, 2 of these will be used for setting minute and seconds, and then the other one will be for putting it into calibration mode. The 5th switch that's on the board, but only the 4th one that we're populating, is a reset. Sometimes your code gets a little wonky, or you just want to start it over from scratch, or for whatever reason, you want to be able to reset your code. So this one down here is a reset switch. You can kind of see it's labeled reset on the board there. That is a feature that they included on this prototyping board. Make sure that all your buttons go all the way down. See how that one's kind of up a little bit? Push it all the way in. Make sure it's all the way down on the board before you solder. So I'm going to go ahead and solder these buttons in, making sure not to burn myself. Let's take a look at our buttons. I think I see a whole bunch of buttons there. The minute and hour, and then the calibrate, and then the reset. And they are all flush with the board. Oh, that one looks like it's sticking out just a little tiny bit, but I think it'll be okay. Yeah. We've also got some LEDs and their current limiting resistors. We'll go ahead and populate one of these because I did put a LED tick-tock on the code. Now, one thing to note about the LEDs, I don't know if you'll be able to see it in this camera shot, but there's a little bit of a flat side over on one side, and then the other side is still rounded over there. The flat side, I can never remember whether it's the anode or the cathode, but it's one of the 2 sides. These devices are polarized, and you need to make sure they go in the right orientation. If you look at the board, you'll notice that the outline has kind of a flat side on the outline of the diode. So you make sure that the flat side of the diode of the LED goes into the flat side on the board. So I'm going to do that. There's the flat side on that side and goes into that side of the board. We'll go ahead and push that in. If you were making this kit as a general prototyping board, you would go ahead and populate all of these, but since this is going to be a special purpose application, we know what it's going to be doing, and we know that there aren't going to be 3 other LEDs that we care about. I'm not going to bother populating them. We're just going to keep it a minimal board. We will cut off the excess leads. There you go. So we have an LED, but we don't have its current limiting resistor. I need to put its current limiting resistor in there. So they come in pack of 4 like this. I'm just going to take one out. Just literally pull it out of the sides. Now, look at the board. The pins, the holes on the board are awfully close to each other there. So I'm not going to be able to do a standard bend on a resistor where it looks like that. Instead, we are going to have to make this a vertically mounted resistor where the bend looks like that. So I'm going to go ahead and push this in. Resistors are non-polarized. It doesn't matter which way they go in. Get in there. There we go. Put the resistor in. On the flip side, on the back side of it here, I am going to bend these wires out. Oops, wrong way. Bend these wires out just a little bit to hold it in place while I solder it in, because that way the resistor won't fall out. Trim off the excess leads. All right, we've got a resistor, or we got a LED and our current limiting resistor. We got our switches. I think that's about it for all the components that come on. The rest of this board, they have a couple of servo outputs over here that you could hook up if you wanted to run some servos. We're not going to be using any of those. These two 1x4s are the connections to the switches and the LEDs. Normally, the kit has us putting in these female socket headers on top so that you can use the breadboard wires. We're not going to be doing that. We're going to be hardwiring it. So again, I'm not going to put these in. That's pretty much it. Now we need to start soldering up the rest of the board.
We actually had a good question from the chat room. They were wondering why he wasn't putting more of the components on this Proto Shield. Well, it's because this is final assembly.
Yeah.
Right? Yeah. Because if you want to see what it looks like using a breadboard, what you want to do is watch the crossover Coding 101 episodes, because he just puts the components in and then he jumpers them. So if you want to test first, go ahead and use the actual breadboard Proto Shield. This is final assembly Proto Shield. In other words, this Proto Shield will never be used for anything else.
Yeah. And he is very fast at soldering.
I know, right? Do you see that? Actually, I slowed that down because I was like, whoa, what did you do?
Whoa, we had to use a high
bionic.
frame rate camera to capture it. Yeah.
If you do want to continue with the entire project, we're going to be doing it over the next 2 weeks. But he's, again, only going to show you the hardware on Coding 101, on know-how. On Coding 101 is where you have to go to find the software.
Yeah.
And the nice thing about this is right after this set of episodes is done, I'm going to show you how I repurpose the hardware and the software to do something else that's actually very, very cool with no additional work required. And this is one of the things about the world of Arduino that you start to notice, which is one project leads to another, because you just start adding inputs and outputs, and you're good to go.
Yeah, and the more you play with it, the more you find other projects to do.
Right. And yes, High Tech is saying always keep your solder tip clean and tinned. Absolutely. That's not just a safety tip. That's not just a pious platitude. If you don't keep it clean and tinned, what's going to happen is your tips are going to corrode. And when they corrode, they look like they do in my soldering.
Oh, yeah, I was going to say, if you've seen any of Padre's soldering segments.
I'm always really lazy. And the tips end up looking disgusting. They'll still kind of work, but you get messy solder joints, and it's not, if you buy something nice, take care of it.
I think you just do it to prove that it can be done.
I have a really nice kit, and you never see it on camera.
Because you don't want to get
mess it up. I really don't.
It's like buying a toy and leaving it in the shrink wrap.
It's like my fine control soldering iron. And the problem is when you solder on camera, you're always like doing weird angles and it doesn't turn. Never mind. Okay. Now let's go ahead and jump into a little bit of feedback, because it's been a while since we've had a chance to listen to what the folks in the chat room and in our Google Plus group have been saying. Brian, do we have our first winner?
Our first feedback question from our Google Plus is, what is your network tester? And that's from Daniel Lott, and he wanted to know if we could identify the Fluke network tester that you used on episode 129. He couldn't actually make out what was written on it, even though it was in 720p.
Yeah, sorry about that. I thought I mentioned it, maybe not. I was using this. This is an old Fluke Networks net tool. They don't actually sell these things anymore.
So eBay?
eBay. Now, if you were to buy this when it originally came out, it was like $1,500. Not anymore. You can actually get one of these for between, the lowest I've ever seen it is $100, but that was for one of some pretty bad condition cosmetically. It still worked, just didn't look great. And they go all the way up to like $500. So, one of the nice things about this is it's not just a cable tester; it's a network tester. So it will test your DHCP server, your DNS. It will actually look for continuity. It will tell you where the break is, because this will do the return time. So it knows where there's a break in the cable. But one big disadvantage, and that is this is only 10100. So this does not test gigabit networks, which is actually not a big deal, because we're not looking to verify gigabit runs. We're actually looking to test continuity and then test services.
Especially if you made your own network cable.
Right. Which brings us to the second.
Do we have an example of that?
Yes, we do. This is something else that you can get. You can buy this brand new. This is about $200. This is one of their Intellitones. Now, the cool thing about the Intellitone is it isn't just a cable mapper, it's also a toner. So I can plug this side into the toner, and this side will actually allow me, if I get close to the cable, it will let me like, oh yeah, that's the one I'm plugged into. So like if you've got a project where you've got a bundle of cables, or you're trying to figure out which cable goes where, you plug this into one end, and then you can use the toner to find exactly what cable that is.
And that works because it's sending a signal down the line, and these are basically like little antennas?
Antennas, right. So it's just sending a tone down the line. Enough of that RF energy comes off, and this is like a radio receiver. So it's just receiving the signal, and it amplifies it. But
that's cool.
It has a second mode, and the second mode is if you plug the cable into both ends, it will actually do a cable test. It's got these 8 LEDs that will tell you whether or not that particular lead, 1 through 8, is connected properly. Now, Brian, I actually got this cable from your desk.
Yeah,
I think
this is my handiwork.
This is your handiwork, so let's go ahead and turn on the cable map and see what it looks like.
Oh, what?
Okay, well, the first two are good.
Bink, bonk, and then bloop, bloop,
Yeah,
bloop, bloop.
The bonk sounds not good. The bink's good.
Okay. And that's what the noise should be at the end of the line. So 2 of my connections are okay. The other
You got
ones are
25%. No, it's a start. It's a start. But again, this is a multi-purpose tool because this allows you to locate cables as well as testing them. Now, I know that's still a lot. $200 to $400 can be kind of pricey for the newer versions. This is the Link Sprinter, and this will actually go all the way down to $100. This is a new product from Fluke. This will do cable testing, but it does it in a weird way. You actually start up an account on Fluke's web server, and you test a bunch of cables, and it will actually upload the results to the web server, and then you can check them from your computer, which sounds convoluted.
It does.
But then it's like automatic documentation. It documents your house.
Huh. Is there like a mobile app? Because I could see that.
Yeah, there's a mobile app too.
All right.
So, I mean, I like Fluke Networks just because I've used them for so long. They're really high quality tools. They never break unless I'm trying to break them.
Yeah, okay.
I have. It's a review thing. But yeah, they are pricey. If you just want super simple cable testing, go to a place like Monoprice, and for $30 you can buy something that will just literally tell you if electrons are passing from one side of the wire to the other.
But if you're going to be wiring maybe not only your house, but maybe like relative's house or something.
It's nice to have a little something.
Yeah.
And I know people who will, like, their cable tester is they'll plug a laptop in, and if it works.
If I can get on the internet, we're good. Yeah.
Hey, I'm not going to make fun of that. That's fine. And, you go with what you've got.
Yeah.
But sometimes it's nice to have nicer.
Yeah, especially if you're laying more than one cable.
Yeah.
Cool. Well, I guess, should we move on to
Let's
our
go
next
and move on to the
feedback
next one.
question?
Who do we got?
So we've got John.
Brian. Brian.
What?
So I'm sorry. I'm looking at our network rundown here.
Yeah.
Man.
Looks like we actually don't have an ad on this episode. So we should probably cut it short. We don't unpack the episode with too much free knowledge.
Whoa. I mean,
you were the one who told him to take a bigger role in the show, and so this is what he does.
the power has gone to his head.
Well, fine.
We've got so much more knowledge.
I've got responsibilities here, Brian. It's all sorts of stuff.
I did. You know what? I need him to keep us in check, Padre.
Fine.
Yeah.
Fine. All right. We'll just end the show then. Fine.
We'll save him for next week.
All right, kill the lights.
Let's go. Thanks.
All right, thank you.
No, but seriously, thank you very much for staying around for this episode of Know How. I know this was a lot of material, and especially since we gave you a parts list, we are not going to leave you in the dark. On the show notes page, you will have everything spelled out. We will take everything from our notes and put it into the show notes.
I
so
just
you know
copy
exactly
what Padre puts in the doc and then paste it on the website.
And where do they go for that?
They go to twit.tv/KH. And not only can you find our show notes, you can find past episodes, which is extremely handy when we are going back on projects about like soldering bullets and our quad projects and everything else. And there's handy little drop-down menu for downloading the episode to your preferred device.
Absolutely.
So if you have a Zune, like Alex, I'm sure you could.
My Zune died.
Your Zune
finally
died?
died?
Well, you should have been smart and bought like 2 or 3 Zunes like Alex did.
I have a spare one just in case.
Strategic Zune reserves. Is that what he's got?
I think he even has like, what is that little phone? The kin? You have the kin?
I've got a kin somewhere.
Yeah. I saw it on his
had one of
desk the
those.
other
I
day.
actually
And it
did.
like flips over. And
Wasn't that was released for like 30 days?
Yeah, I think that the big joke was that when they discontinued it, they had to notify their next of kin. But I digress.
Okay. If you've got really bad puns like that, you're also probably going to want to check out our Google Plus group. It's 8,000 members and growing. I think it's like 81 something right now.
8,000 strong.
Tell your friends to join in. It's a great place to get information.
Yeah, it is. And it's a cool place to check out and see other people's projects and get ideas from those. And I know that a few of the projects we've done have been outshined on Google Plus. So thank you. And all right, fine, just thank you.
Stop it. And we know we used to give you a link for it, but just go to Google Plus and look for Know How. There's only one Know How group. Come join in. Ask questions, answer questions, post your projects. We'll take your questions on the air. One of the other things that we did, if Alex hadn't stopped us, we actually had a feedback of a very cool Arduino project that one of our know-it-alls did. We're going to show you that next week.
It's a tease now.
It's a tease.
Were going to show you, but now we're just going to draw out the sending.
Because of Alex. Also, don't forget that you can find us on other social media venues, specifically on Twitter. You can find me at twitter.com/PadreSJ.
And I am at cranky_hippo. And if you want to complain about the episode being short, you can go to @Anelf3 to follow Alex on Twitter.
In fact, the power of Padre compels you to go to Twitter and complain to Anelf3 and tell him that we want more know-how.
The power of
Because in reality, it was totally my decision.
Yeah, absolutely. We totally didn't discuss it off camera.
No, we did not at all. Also, don't forget that we are getting back into our quadcopter episodes, which means next week. This is a tease. This is an actual tease. We're going to be continuing the Arduino clock, but we're also going to be doing the first episode where we're going to show you mods that you can make to your existing FPV 250. So if you built the 250 from 3 months ago, we're going to start to give you little tips, some of them completely free, that can increase your performance and stability.
I just want to fly, Padre. Can we just do some FPV?
We actually get, I brought that. We can play with it later. Until next time, I'm Father Robert Balacer.
And I'm Brian Burnett.
And now that you know how,
go do it. Kill the lights.
go home.
We're done.